Hello everyone, welcome back. So let's try out some example problems from thermodynamics right now. And what do we have here? Well, we have a 1.8, there we go, meter cubed rigid tank. It contains steam. Let me get my little underliner here. There we go. So 1.8 meter cubed. It's rigid. We need to know that. Steam at 220 degrees Celsius. 1/3 of the volume is in the liquid phase, and the rest is in the vapor form. Properties of steam at 220 degrees Celsius are given as follows. Perfection. And what are we trying to find? We're going to find the pressure, quality, and density of this steam. So, what is the pressure? What is the quality? And what is the density of this steam? Okay, as a note, this is part of a series of example problems I'm doing. I have more of these in my members videos, so if you like what you're seeing here, become a member. You'll see a lot more example problems coming out soon for thermo there. But this one's freebie, so you can get a little taste of what you'll see there, and I'll make some more freebies as well. Now, let's see here. So how we're going to find the pressure. Well, this is actually really easy. Why is it easy? Well, it told us something very important. I've got my tank. Its volume is 1.8 meters cubed. And it tells me that there is 1/3 of the volume that is liquid, and that 2/3 of it is in vapor form. So this tells me right off the bat that this is a mixture. And since it's a mixture, that means my pressure is going to be equal to my saturation pressure. What is the saturation pressure, you ask? Well, if you are a mixture, that's the key word here, of liquid and vapor, then there's only one pressure you can be for every temperature, and only one temperature you can be for every pressure. So there's only one pressure that goes along with 220 degrees Celsius. And I can look that up and find it in my table. So we're going to do that right now. Okay, give me a second. I'm going to jump over to the McGraw-Hill textbook using some movie magic, and we'll see that. So here we are in the McGraw-Hill textbook. This is the appendix. I was in SI unit, so I'm in appendix 1. And it says it was a saturated mixture because it was both liquid and vapor. And so I need to go to these saturated tables. Now, you're like, oh, I'm trying to find pressure, so let's go to the pressure table. That's not what we're going to do here. We know the temperature. So whatever you know, go there. I know the temperature. I'm going to go to the temperature table. It always jumps right past it. And so here I am, saturated water temperature table. I'm going to scroll down until I get to 220 degrees Celsius, which is right here. And then all of this line, because I know it's a saturated mixture at this temperature, all of this is going to show me my properties for this particular state. And so this right here, this column is the pressure column. And so for 220 degrees Celsius, I'm going to have a pressure always, every single time, for a saturated mixture of water of 2,319.6 kilopascals. So that is my answer to that very first problem right there. And I'm already done with that first step. Not too bad, right? Okay, so that equals 2,319.6 kilopascals. And we are done. Glorious. Okay, now let's keep on moving on. So this guy's check, done with that one. As a note, these properties right here were taken from that same line. I could have gone and found them if I wanted to. I'm going to pull back up right this second though. So now we want to find the quality. So the quality is simply equal to my mass of vapor over the total mass. It's equal to a lot of other things too. It's equal to V minus Vf over Vg minus Vf. It's equal to H minus Hf over Hfg. That's enthalpy there. So there's lots of ways you can calculate this, but for us, this is going to be the easiest one because it told us the volume of vapor and the volume of liquid. And I can use that to figure both the total mass of vapor and liquid I have, and then from that figure out the quality. So let's do it. So first off, my volume. You can see that it's 1.8 meters cubed. It says it's 1/3 liquid. So I can say that my volume liquid is going to be equal to a third of that, so it'll be 0.6 meters cubed. And my volume vapor is going to be equal to 1.2 meters cubed. And now what I'm going to do is I'm going to go ahead and find the mass of liquid and the mass of vapor. How am I going to do that? I'm going to do that using my specific volumes. Makes it really simple. Specific volume, I'm trying my best to draw a lowercase v here, is equal to the actual volume, which I'll put a line to make it easier, divided by the mass. And so if we rearrange that a little bit, what we get then is that my mass is equal to my volume divided by my specific volume. I'm going to do that for both my liquid and my vapor. So I gotta make sure I keep those numbers up so I can actually see them. There we go. So mass liquid is going to be equal to, let's see here, I've got 0.6, that's meters cubed, over 0.00119. And my mass of vapor is going to be equal to 1.2 meters cubed over 0.08609. That looks good. When I plug it into my calculator, what do I get? And for liquid, it pops out, let's see here, yes, 504.2 kilograms. And for vapor, it pops out 13.94 kilograms. Okay. And so now let's go into this quality equation again and get this finished out. So my quality is going to be equal to my mass of vapor, which is the smaller one, that's 13.94 kilograms, over the total mass. So 504 plus 13, that comes out 518, yes, 518.14 kilograms. That's the total, adding those two together. And that gives me a quality of 0.0269. Okay, so that is my second step done. The last thing it asks for is the density. And you can do this either the easy way or the hard way. We're going to do the easy way first, and then I'm going to show you the hard way, which your book is kind of thinking you're going to do it is. Density is simply equal to mass over volume. You have a mass, that's the total mass. You have a volume, 1.8. So if I plug that in, what do I get? I get 518.14 kilograms divided by 1.8 meters cubed. And that comes out to be somewhere around 287.8 kilograms per meter cubed. So there we go. That was super simple. Or we can do it the slightly harder way. Why am I showing you the slightly harder way? Because a lot of times you're going to have to use this. So if you have a saturated mixture, that means that I have part liquid and part vapor, or, well, we'll stick there for now. Then that means that my properties are a mixture of the vapor properties, the G properties, and the liquid properties, the F properties. It's somewhere in between those. Those are my boundaries, with liquid being on the lower end and vapor being on the higher end. And so I can find any of those properties using my quality. So my specific volume, which is related to density, is equal to my specific volume of saturated liquid. We start there and we start going up, plus the quality times the difference between my specific vapor and specific liquid. I'm not going to bother plugging all those numbers in because guess what? It's going to come out to be, well, not the same number because this is specific volume. It'll be equal to 0.0035 meters cubed per kilogram. And then if I invert that, because density is equal to 1 over specific volume, I'll get something very, very close to what I had before. Only difference there will probably be some, like, calculator errors. A little bit of rounding. There we go. And so that is this problem. So hopefully this helps you. And once again, if you're looking for more example problems, consider becoming a member. It helps keep this channel going. It's not all that much, just $1.99 a month. And you'll see a whole lot more example problems there. So thanks for watching, and I'll see you all later. Bye-bye.